Hi, I'm Annapurna Agrawal and this guide is about TypeScript, a broader look. This will give you a technical introduction to the TypeScript language. This is for anyone who is going to start working with TypeScript. Before getting into any syntax, we will first have an overview of the language, its features, the problems it solves, and if it is a good fit for our project. We will see the relationship between TypeScript and JavaScript. We will learn creating and configuring TypeScript projects. There will be a few code examples, and this includes writing and debugging them too. We will also have a look at the approach you should go for if you want to convert your existing JavaScript project to TypeScript. And after this big picture understanding of TypeScript, you will be able to figure out where TypeScript fits and what other technologies you can use it with and the tools you need. You don't have to follow along with everything I type in this guide. Just sit back and watch. However, if you want to try out some stuff, sure, go ahead. You will have a context and good understanding of TypeScript by the end of this. Before we dive into this guide, there are a few things you should know already. You should be familiar with JavaScript, not an expert level, but at least the basics. You should be well acquainted with HTML and CSS and some general processes of typical web development. You need to know all this because TypeScript is not an independent and self-contained language. For example, when we talk about Swift or C# or Java, we do not need any other supporting language. But for TypeScript, JavaScript is the backbone. TypeScript exists to improve JavaScript. It is common to come across the phrase, TypeScript is a superset of JavaScript. This actually means that TypeScript has all the features that JavaScript has, plus it has its own new features. JavaScript is the baseline. So when we learn about TypeScript, we take this approach. We learn about the additional features of TypeScript and the problem it solves that JavaScript has. That's the reason I mentioned earlier. To learn TypeScript, we need at least the basic understanding of JavaScript. JavaScript support is built into pretty much all the browsers that exist till today. Almost all the websites and web applications depend on JavaScript even to work. Be it the web-based email, document editing, calendars, maps, all need JavaScript. However, creating and managing complex applications using JavaScript has become increasingly difficult. Back in mid-1990s, when JavaScript was introduced, its main purpose was to provide basic animation and functionalities in a web page. It was friendly, forgiving, and flexible. But today, these features of JavaScript has become an issue while developing complex apps. For example, we can't define a specific data type for a variable. This leads to inconsistency in our project. There is no interface or header file. Even the tooling and the debugging support is not to the mark. Despite all these challenges, JavaScript is everywhere. There are so many design patterns, best practices, libraries, and third-party framework to support JavaScript. And on the other hand, we have TypeScript. TypeScript can help us to build complex JavaScript applications. Yes, you heard it right, JavaScript applications. Because TypeScript code compiles to JavaScript code. The compiled code is clean and standardized JavaScript code, not minified, not compressed. To give you another example of such a process, we have CoffeeScript which compiles to Dart and work the same way as TypeScript and JavaScript does. Now, when we switch to using TypeScript from JavaScript, we don't have to change anything about how we run our application, whether it is client-side, server-side, framework, libraries, or the host. Everything remains the same. By using TypeScript, we just give ourselves few more features to make our coding for application development easier. That's it. Now, let us see few of these features which adds to the benefit of TypeScript. Feature number 1. We get static types. Static typing is when the compiler enforces that a variable uses the exact same type of value as mentioned. JavaScript, as we all know, is very flexible about its data type. It is so flexible that even when we want to provide a type information for a variable, we cannot do that. A variable can start as a number type, and post that we can assign any value to it, be it string, boolean, or even null or undefined. This feature of JavaScript makes it easy to write simple applications. But when it comes to complex application, this becomes a cause of chaos and unpredictable behavior of our application. JavaScript is an interpreted language. All the type information is evaluated at the runtime. Debugging complex applications at such time becomes very inconvenient and complicated. TypeScript has addressed this exact issue of JavaScript. If we assign a value to a variable, let's say here 5, and then if we try to assign a string value to the same variable, we are going to get an error. You cannot assign a string type value to a number type variable. In TypeScript, we can add type constraints to the variables, function parameters, and properties. We can mention if a variable has to be a number or string or boolean, and even the type of a value the function will return. This static type checks helps to maintain consistency throughout our application. In case of any mismatch, TypeScript uses its compile time error feature. This shows any error immediately, and thus our coding is made a lot easier. Next benefit of TypeScript is that we can keep all our codes well organized. We can arrange the codes to groups and modularize and manage them easily. We can use the object-oriented programming techniques with TypeScript. We have the concept of classes, properties, methods, objects, constructors, SS specifiers, inheritance, and everything else that an OOPS-based language has. For SS control of our variables and functions, we have namespace and modules in TypeScript. We have interfaces in TypeScript where we can declare the expected methods and properties without implementation. Now, for JavaScript, classes were introduced just recently with ECMAScript 2015, so we can use that as well. But prior to that, we did not have any such concept for JavaScript. So if we use the OOPS principle in TypeScript, it can compile it to JavaScript that will work with all ECMAScript, be it ECMAScript 3 or 2015. Now when we look at the official GitHub repository for TypeScript, we have a list of goals for it. This point number 6 says TypeScript will always align with current and future ECMAScript proposals. So TypeScript is not replacing JavaScript. Rather, it is just supplementing it. The next benefit we are talking about is the awesome tooling support of TypeScript. Writing, testing, and debugging the TypeScript code is way more convenient and quick. TypeScript allows basic tooling features like auto-completion, color coding, and refactoring, to advanced tooling features like checking consistency about how we are defining and using our data, detecting unused data or unreachable code, and generating the source maps, meaning when we execute TypeScript code and run it in the browser actually generates the JavaScript code. And this JavaScript code can be mapped back to the equivalent TypeScript code as well. This way, we can debug our code in TypeScript itself. However, to make use of all these mentioned features, we need an IDE that is TypeScript aware, be it a built-in support or using an extension. TypeScript is supported in many IDEs like Visual Studio, Sublime Text, WebStorm, Atom, Eclipse, and Vim. There are many more other than this. I use Visual Studio for TypeScript. It is free, it is cross-platform on Windows and Mac OS and Linux, and it has an awesome TypeScript support already built in. So let's see TypeScript in action now. We will start with writing Hello World in TypeScript. We are aware of writing code in JavaScript. We are also aware how easy it is to write Hello World in JavaScript. We also already know that a valid JavaScript program is a valid TypeScript program. So that's it. You already know how to write Hello World in TypeScript. But wait, don't go yet. Here's the catch. Hello World to start with is oversimplified and unrealistic. But here is the whole idea of Hello World, isn't it? To get an idea about any programming language. For example, when we write a Hello World program in C++, we realize that we need an include statement here. Or in C#, M for the main is written in uppercase here. However, there are some languages where Hello World does not help much. What we just saw is one such case. The whole point of using TypeScript is in contradiction to writing this tiny Hello World program. We don't need TypeScript as a replacement of JavaScript. We need TypeScript to develop really complex and non-trivial application. Only then we get to take the advantage of real benefits of TypeScript. We can see this as one of the goals of TypeScript as well. Provide a structuring mechanism for larger pieces of code. If all somebody wants with JavaScript is a few lines in a DOM content loaded event, they are not going to see a lot of benefits of going to TypeScript. However, we can use TypeScript for writing short pieces of code to learn it and to compare it with equivalent JavaScript code. So let's jump right into Visual Studio Code to learn TypeScript. Before getting you set up with the development environment, let me show you a quick demo of writing and compiling TypeScript. This will give you a quick idea of everything we have discussed until now. So here I have created a basic HTML file in my demo folder. It is a basic HTML file with just a heading. No JavaScript or TypeScript yet. Now I'll create a new TypeScript file and save here in the demo folder. Name it index. The TypeScript file has extension ts. And now in this file I'll add some code. A little more than hello world. For now, don't worry about memorizing any syntax. Just sit back and see how TypeScript works. So here I have defined a new class user. It has one property name, one constructor, and a method welcome user. I will now instantiate an object of the user class and call the welcome user method. So here is my new instance of the class, and here I have called the method welcome user and assigned the return value to a string variable welcome message. Now I'll put this result string in the heading of the web page. Here I have taken the reference to the h1 tag in my HTML page, and here I'm updating the text in it. Our basic TypeScript program is now ready, but it is not going to do anything yet. We have not included any JavaScript code out in our HTML file. But wait, we don't have any JavaScript code yet. Where will we get it from? Now this is where we will use the JavaScript code which has been generated from the TypeScript code. We need the TypeScript compiler for doing this. Now I'll quickly open the terminal from the VS Code itself. The terminal opens in my current folder. Now to run the TypeScript file, I'll just type tsc followed by the TypeScript file name. Now remember that I have everything installed in my machine. You are yet to do that. So just sit back and watch. On hitting enter, Now this takes my TypeScript file name and creates a JavaScript file with the same name. Here we have index.js. Now opening the file side by side, now you can see both my TypeScript file and my JavaScript file. Some blank lines are removed, our comments are removed, and here my class code and the TypeScript has been converted to the prototype-based functionality of older style JavaScript. If I link this JavaScript file, remember, not the TypeScript file, the JavaScript file in the index.html file, we can see we have got our heading updated. Despite being a simple example, I'm sure there are many questions bubbling up on your mind. Can I change the generated JavaScript code? Yes, of course you can. It is simply a JavaScript file. But when you make changes in your TypeScript file, the JavaScript file will be regenerated and your changes will be lost. So it is best to make changes in the TypeScript itself. Do I have to execute TSC after every change in TypeScript? No, we can set up an automatic watch which will automatically regenerate our JavaScript file with any changes in our TypeScript code. It is easy. We will see that. Like TypeScript compiler, what are the other tools required for using TypeScript in an existing project? My project has a defined set of dependency analyzer and minifying and bundling tool. What do I need apart from it? It doesn't need anything else. The idea is to add TypeScript to our existing project without having to change anything in the existing tool. There may be few other questions like the generated JavaScript file will always be the same name as the TypeScript file? Will it be in the same directory? Can I combine multiple TypeScript files into one JavaScript file, or can I split them? Where can I see the errors? What happens in the TypeScript class? We will see all of this. But first, let us get your TypeScript development environment set up. To get started with TypeScript, we need just two tools. The first is IDE. You can choose any of this. I'm using Visual Studio Code. And the second is the TypeScript compiler known as TSC. The easiest way to set it up is to begin with Node.js. Don't worry, you don't need to be familiar with Node.js to work on TypeScript. We install Node.js to use the great infrastructure and the tool set that it provides. Most importantly, NPM, the Node Package Manager tool. So first you need to set up Node.js in your machine. To do this, you can simply go to nodejs.org and move to the Download tab. Choose the correct version for your machine, Windows or Mac, and the respective version. Follow the installation instruction and you will be good to go. NPM had started as a part of Node, but now it has turned to a great tool to install and manage other development tools and dependencies. It also deals with versioning and updates. And for the IDE, Visual Studio Code, you can just go to code.visualstudio.com and download Visual Studio Code for your system. Choose your system from this drop-down, follow the instruction for installation and you'll be good to go. So now you have the Visual Studio Code IDE and Node.js installed in your system. Now we need to install the TSC, TypeScript compiler. To install TypeScript in your machine, we'll first move to Visual Studio Code and we will use the terminal from the IDE itself. From the terminal option, open new terminal. So to install the TypeScript compiler in your machine, now first make sure that you have npm installed. To do that, type npm-v and this gives you the version of your npm. So we have npm installed in our system. Now we need the TypeScript compiler. To do that, npm install -g TypeScript. I'm using the G flag to install TypeScript globally. Hit enter. And here we are getting our TypeScript compiler installed. And that's it. Now we have our TypeScript compiler installed in our machine. To check if it is correctly installed, type tsc-v. This will return the TypeScript version. So as of now, the latest version of TypeScript is 4.5.5. tsc-h will give the help list of compiler option. And here we have the common commands and the line flags that we can use with the tsc command. We will check out a few of them in a couple of minutes. But first, let's see some of the TypeScript project configurations. TypeScript doesn't require any special folder structure. We can organize the file as we want. However, it will still depend on other frameworks that we use with TypeScript, like Angular or Node, if we are using it in the server side or the client side. We need to take care of few project level decisions. How to keep the TypeScript code separate from the generated JavaScript source code. What version of JavaScript or ECMAScript do we want the compiler to generate? We also need to take care that in case of multiple TypeScript files, shall we combine them all into one JavaScript file or keep them separate? We saw a basic tsc command to compile one TypeScript source code into one JavaScript source code file. But like most of the command line tools, tsc also has a bunch of different options we could specify when we run it. Now in the terminal, let us try out few of them. tsc-target es2015 -out dir js index.ts. This implies my target JavaScript version to compile the TypeScript code is ECMAScript 2015 and the output directory where I want my compiled JavaScript file is JS. When we execute this, we have a JS folder created here with index.js file, which is my TypeScript compiled code. This JS file which we had generated earlier, we had not specified any target ECMAScript version. So this was converted to an older prototype-based ECMAScript version. However, this new index.js file is compiled with new syntax here, where it uses class. The ECMAScript 2015 version supports classes. So this way we can customize and control our compile options. However, it is not always convenient to type in all the details like the versions or the target for all the TypeScript in the project. So to resolve this, we can set our preferred option which will be taken while compiling the code. And we do this in the tsconfig.json file. It is just a text file in JSON format, a plain text set of keys and values. We can create this config file easily by running tsc-init in the command prompt. Hit enter and here we have an editable configuration file, tsconfig.json. Of course, you can create it manually as well with just the required options. Now whenever we run tsc, it first looks in the current directory for this tsconfig.json file. If found, it takes up the specified options, else it just goes ahead and does a standard TypeScript file with default settings, like compiling the JavaScript version to ECMAScript 3 and generating a JavaScript file in the same place with the same name just ending in .js. Now most of the options here are commented out. However, let us check out few of them. To start with, we can choose the target JS version we want to generate. Here we have ES 2016. Now we can also specify the output directory for the generated JavaScript file, which is a relative path to whatever we are at right now. Uncomment this, and here I can specify my output folder. I'll also uncomment this setting here of no unused locals, and this will tell me about things like did I create a variable and if I never used it. I'll save the changes, and now when I run tsc in this directory, I don't even have to provide the TypeScript file name. It will automatically look for all the TypeScript files both in this directory and any subfolders and compile them with this settings, placing the generated JavaScript in the JS folder. Now we can't cover all these configuration options in this guide, but I think this gave you a pretty good overview of the tsconfig file and its purpose. Now let us dive deeper into TypeScript language itself. As we explore the coding part of TypeScript now, in this guide, I don't want you to learn and remember the syntax as of yet. Just understand how it works and mark its benefits over JavaScript. In my editor, first of all, I'll move all these files which we have previously created in a folder called Introduction. And here I have the Introduction folder. Now here I'll create another folder Basic, and we will write all the code for this demo in this folder. So let's start with the first benefit of TypeScript that we saw, that is static type in action. We know in JavaScript there is no way to define the type of values a variable can store. So if I define variables like this, let first name is equal to Sonam, age is equal to 29, membership is equal to true, we can clearly infer that the first name is string, age is number, and membership is boolean. But the problem here is I can even assign a number to the variable first name. First name is equal to 100 because in JavaScript the variables are not typed. Now if I define the same variables in TypeScript, so in my types.ts file, I have pasted this code. First name is Sonam, which is of string type, age 29, which is number, and membership, which is boolean. This is what we have inferred. Now when we mouse over this first name in the TypeScript variable declarations, we can see the syntax. Let first name colon string. This exactly is called type annotation. Looking at the value in the first name, TypeScript infers it as a string. Age is of type number and membership is of type boolean. So this type inference works when it is obvious what kind of data is being used for a variable. If I reassign a number to the first name, I get an immediate error. Type number is not assignable to type string. I can only assign string value to the first name. Let's comment this out. Now, if I declare a variable without any value to it, TypeScript infers it to be of type any. We can assign any value to it. It now acts like a JavaScript variable. But the best practice is to use explicit data type wherever possible. Now, if I want to mention that any var should hold a string data type, we will use the same syntax that we saw above in the type annotation. Variable, colon, and then the data type. So anywhere is explicitly typed as a variable of type string, even when no value is assigned to it. So this way I can even give the explicit types to the variables here. But however, it is not important because we have values already assigned to it. We can also use this typing information when we define a function, its parameter, and the return type. Let's say function welcome user. Now for the function parameters, since we don't have any values assigned to them, we should explicitly define the type. Let's say name be of string type and is active be of boolean. So this way we give the type to these parameters. Now we can also define the return type for a function. To define that, just put the colon after the closing parenthesis and mention the type of data the function returns. Let's say number here. So here our function welcome user takes two parameters, a string type and a boolean type, and returns a value of number type. But here we have an error which says this function must return a value. So since we have mentioned the return type, TypeScript will make sure that this returns a number. If the function does not return anything, this can be void as well. Now let us make some changes in this function and let me show you another property of TypeScript here. I'll remove this return type altogether, and here I'll update the code so this function returns a string type value. Keeping it simple, say hello and the name of the user. When I call this function and assign the return value to a variable, now mark here, TypeScript has already inferred that the type of this message variable has to be string, because this welcome user function returns a value which is of string type. So this was a quick overview of explicit types and type inference in TypeScript. Sit back and seep into this fact that how this small feature in TypeScript can make development easy and keep our code consistent throughout the application. And while you do that, let us now jump into defining classes in TypeScript. I'm assuming you're already familiar with the object-oriented concept in the programming, and you understand properties, methods, instances, constructors, inheritance, and other object-oriented based terms that I use. Earlier, we saw a simple example of a TypeScript class user. Now I want to show you that I have commented out all the codes in index.ts file because it was giving me an error telling that I have already defined the class user. But since this is for the demo, I have commented this out for now so that we can work in this new file classes.ts. So coming back to our TypeScript class, my user class has one property, a constructor method which is called automatically when we create a new instance of this class, and one regular method, welcome user. The property declared here is declared very simply without any var or let. I have used explicit type string here. And here I have created an instance of the user class, and the constructor takes one parameter which is string. So here I have passed the string value Binod. TypeScript makes sure that we create a new instance correctly. For example, if I comment out this line, I will get an immediate error here. Or let's say if I don't pass a variable here, again I get an immediate error. So this way, TypeScript gives us the errors instantly while we are coding. Now TypeScript also supports inheritance. And to use this feature, we use the extends keyword. Here I have defined a class premium user. And this premium user class inherits the data and behavior from an existing class which is user here, and now we can provide additional behavior and data on top of the properties of the user class. So this is how we can use inheritance in TypeScript. TypeScript also supports SS modifiers, the public, private, and protected. The SS specifier helps us to control whether the property and the method of a class will be accessible to the code outside of the class or within the class. By default, the members of a TypeScript class are public. They are accessible outside the class as well. If we make this function private, we can call this method from within the class itself, and hence we have an error here. If I make it protected, This method can only be called from within the class or any class that inherits from this one, but not elsewhere. Hence the error again. So I'll keep it public for now. TypeScript also supports other OOPS concepts like setter and getter, read-only modifiers, and abstract classes. However, I'll leave those area for you to learn on yourself. And for this guide, we will now proceed with modules in TypeScript. Now, while working on large projects, it becomes convenient if we divide and arrange our codes into smaller and manageable sections. This is also helpful if we want someone else's code in our project or if someone else wants to use our code in theirs. We have seen the idea of using classes in TypeScript. Our user class in one part of our project might need to know about some other classes, let's say a subscription class maybe, in some other part of our project. Sometimes it might be more than just a couple of classes that we are dealing with. We also need to be able to refer to several classes together at once or load multiple libraries. In JavaScript and TypeScript, we have this concept of modules. In few languages, modules are also referred to as assembly or packages. So we can input modules into our code or we can create modules for others to use it. We need to make sure that everything gets loaded correctly and in right order. Now for a long time, JavaScript did not have any formal way to do this in a right way. So we got several other popular libraries to load the modules correctly into our project, and they were called module loader libraries. If you have an existing large JavaScript project, you are likely to already be working with some kind of such module loaders, like CommonJS or Require.js. But since ECMAScript 2015, JavaScript has got its official way for itself to understand and deal with such modules. And this makes the process relatively simple. There is this setting in tsconfig file called module where we can specify how we want to deal with modules. And here the module is specified to be using CommonJS. So let us check out how we can import or export modules in TypeScript. Coming to the user class that we had created earlier, if we want some code outside this file to use this user class, I will just have to export this. And to export it, I will just add export keyword before the class. Now for other files to be able to use this user class, I've created a file others.ts here. We will just import this user class. The syntax goes like this. Import the class name that we want to import in the curly braces. From uses a relative path to link to the file, but here we don't need the ts or js extension. And now we will use the user class. So this is a typical import syntax. There will only be a slightest change depending on the module loader format we use. So we can safely say that this is more about JS and module loader library and less about TypeScript. So to use others' code in our file, we will have to import it, and to allow our code to be used elsewhere, we will export it. So this was modules in TypeScript. So what's next? How do we proceed further with TypeScript? Of course, we are not going to build an application from scratch with TypeScript only. For example, TypeScript is a default language to use with Angular, whereas it also works very well to generate JavaScript code for other technologies like Node, React, Iconic, or Vue. Irrespective of what technology you use TypeScript with, to get a thorough idea of TypeScript, you can blindly choose this official website typescriptlang.org. This official website is very resourceful. I would like to share some tips to learn TypeScript from this website. Number 1. In this docs section, you can get into all the specifications of the TypeScript language. There is this tutorial section in which you have this gulp option where you can find the documentation and details on building TypeScript into a gulp pipeline and adding stuffs like watchify and uglify. If you have a JavaScript project which you want to migrate to TypeScript, here is the resource for you, migrating from JavaScript. You'll get all the instructions in detail here. Best of all, here is the TypeScript playground. It is an in-browser editor with TypeScript on the left and the generated JavaScript on the right. From the drop-down, you can choose various compiling options. From the examples, you can choose whatever variety of example you want to learn for TypeScript. This is a very quick and very useful way to experiment with TypeScript and instantly see the result. So that was it, a big picture of TypeScript. I hope now you have an idea about the core benefits of TypeScript, the static types, the organized codes, and the tooling support. To dive deeper into TypeScript, refer to the course I have mentioned below in the description. Support us by liking this video and sharing it. Also subscribe to Smartherd. This motivates us to bring to you more such quality content. Keep smiling and have a great time ahead. Happy coding!